Hi, this is Geometry, Lesson 1-7, Writing Proofs. In this lesson, we'll be able to use deductive reasoning to prove theorems. Some vocabularies that we're going to learn would be paragraph proof, theorem, and two-column proof. We know conditional statements and facts and postulates, what are theorems and what is a proof and how do we write them. Let's start with critique and explain. William solved an equation for x and wrote justifications for each step of his solution. So if you look at his paper, he justified each step. So we start with 6 times parentheses 14 plus x equals 108, and that's given. That's where you start from. And then using distributive property, we distribute 6 out like that, and we have 84 plus 6x equals 108. And then using subtraction property of equality, we subtract 84 on both sides. And so minus 84, you get 0, and then 108 minus 84. Then we simplify. And then multiplication property of equality. Is there something wrong with this? We simplify and then we get 24. And then what do we multiply by? Are we multiplying or dividing? Really, well, we can multiply by a fraction, but we can also you can multiply it by 1 over 6, but that also means that we can divide both sides by 6. This could also be a multiplication property. Instead of multiplication, this could also be a division property of equality if he divided each side by 6 instead of multiplying by a fraction. Okay, so can you justify another series of steps that result in the same solution for x? So we can try to solve this in different ways, but we're going to start with the given information. 6 times 14 plus x equals 108, and that's given. How could we go next? Instead of using distributive property, what else could we do? What is another way to solve this? You can divide both sides by 6, so that we have 14 plus x here. We have 108 divided by 6. And that's division property of equality. Now we can simplify and get 18. And then we subtract 14 on both sides and have x is equal to 18 minus 14. And that's a subtraction property of equality. And we have x is equal to 4. You should get the same answer. Okay, so there are multiple different ways to solve the same kind of problem, but the answer must be the same. So let's think about this essential question. How is deductive reasoning used to prove a theorem? We have a theorem 1-1, vertical angles theorem. So vertical angles are congruent is what this theorem is saying. We're gonna have to prove this before we use them. Theorems are not proven until we prove them, but theorems could be proven. Okay, so we're gonna prove that in example 1. First of all, what are vertical angles? Vertical angles are angles that are vertical to each other. So they're not right next to each other. They're not adjacent angles, but they're the angles on the other side of the intersection. Okay, so if you have 4 angles formed by these 2 lines, then angles 1 and 2 are congruent, and 3 and 4 are congruent. So let's prove this. First of all, what is a theorem? A theorem is a conjecture that is proven. Prove the vertical angle theorem. It's already proven. And so let's prove it together so that we can also use this theorem in the future to prove other theorems. So it's given that 1 and 2 are vertical angles. We're going to prove that they're congruent. And a proof is a convincing argument that uses deductive reasoning, using facts. A two-column proof, in which the statements and reasons are aligned in columns, is one way to organize and present a proof. This is the first type of proof that we're going to look at. Two-column proof. You have two columns, with the first column being the statements, and the second column listing the reasons. Okay, very obvious, and it's very clear. Okay, so the first step is always, almost always going to be a given fact. We're going to start with given. Okay, angles 1 and 2 are vertical angles, is the given fact. And then what can we conclude from that given fact? Before we do that, what are other angles that we could use? So if we have an angle between 1 and 2, angle 3, angles 1 and 3 make a line, angles 2 and 3 make a line, so the sum of those angles should be 180 by the definition of supplementary angles. Okay, using this information, where are we going? Because measure angle 1 plus 3 is 180, and 2 and 3 make a supplementary angle as well. They're both going to be 180 degrees when they're added up together. So we're going to make those statements equal to each other. So measure angle 1 plus 3 is equal to measure angle 2 and 3, right? So then, solving for the equation, simplifying it, we can subtract measure angle 3 on both sides because it must be the same angle, right? And so that means measure angle 1 and 2 must be the same, which makes, by definition, the angles congruent. Okay? So now we have proven with the two-column proof that any vertical angles given would be congruent. All right, now it's your turn. Try number 1. Write a two-column proof by yourself. See if you can try by yourself with a given fact that the ray BD bisecting angle CBD. What are the facts that you know? What are the definitions that you know already in order to help you prove that angle ABD is congruent to angle FBD? All right, pause the video, come back when you're ready for answers. Okay, are you ready? Yeah, what do? First of all, you need to write two columns, okay? So the first column would be statements. The second column would be reasons. And then you will start with the given information. Ray BD bisects angle CBE. And the reason is that it's given. And then what do we know about an angle bisector? They divide the angle in exactly half, right? So that means this angle and that angle should be the same, right? They're congruent. So angle CBD is congruent to angle EBD. What is the reason? This is by the definition of angle bisector. Okay? And then what do we just learn about vertical angles? ABC and FBE should also be congruent because they're vertical angles, right? So angles ABC and FBE are congruent by the definition of vertical, oh wait, this is not a definition, sorry. You can say by vertical angles theorem. Okay, I'm abbreviating them, but this is vertical angles theorem. What's the next step? Now, using these two facts that we concluded using deductive reasoning, we're going to use angle addition postulate so that what is ABD? ABD is angle ABC and CBD combined together, added together, right? We're going to add these two to get angle ABD, add these two to get angle FBD, okay? So measure of angle ABD is equal to measure of angle ABC plus measure of angle CBD, and measure of angle FBD should equal to measure of angle FBE plus measure of angle EBD. And what is the reason? By angle addition postulate. So you are using all the postulates and theorems that you have already learned previously. But if you know something that you didn't learn yet, you have to go in geometry. The order is really important. So if you haven't proven it before, we haven't talked about it, then you cannot use it. Okay, so make sure that we have gone over the postulates and the theorems in the past before you use it. So every time we learn a new theorem and new postulate, you should be excited about it because there are more things that you could use to prove. All right, the next step. Now we know that looking at this, how can we combine these together? Because remember that we're trying to prove that these two angles are the same, right? So because they're equal to each other, and we know that angles ABC and FBE are congruent, we can substitute either one of them, right? And say measure of angle ABD should be the same as adding measure of angle FBE instead of ABC. Notice that substitution plus measure of angle EBD. Okay? So by substitution property of equality, we substituted FBE instead of ABC. Okay? And then you can say that, oh, the measure of angle ABD is equal to measure of angle FBD. Why can't we just skip step and then say, oh, yeah, it's obvious that we can make them equal to each other. We need a middle step to prove them and provide reasons about it. Okay, you can't just skip steps. Try to write down as many steps as possible so that you're very clear. Okay, you can't just start from a given and then you can say, oh yeah, because of this theorem, that theorem, you can prove that this is correct. You have to write down the whole steps. Okay, you have to show them thoroughly. Okay, and then yeah, this is because of the transitive property of equality. Do you remember? If A equals B and B equals C, then A equals C. That is called the transitive property. So finally, you can say angle ABD is congruent to angle FBD because the measures are the same, and that's the definition of congruent angles. Yeah, that was a long triad question, but I hope you got it. If you were this close to getting it 100% right, well, good job for you too. Okay, if you have anything close to this, that you have written by yourself, that is great. It's your first time writing a two-column proof, so you've done great. So you can keep practicing writing a two-column proof to get better and better. Just make sure that you write every step and write all the reasons down for each step. Justify. All right, let's look at example 2. Apply the vertical angles theorem. The diagram shows how glass lenses change the direction of light rays passing through a telescope. What is the value of x, the angle formed by the crossed outermost light rays through the focal point? So we see light rays going through here. And then this is the objective lens that it's going to go through. We see a focal point, and the light rays are going to go perpendicular through this lens. And it's going to bisect the angle from the focal point to objective lens. You see that? 11 degrees. And we have eyepiece lens on the other side. So we want to figure out the x, which will be the vertical angle to this angle, which will be addition of these two angles. So just by looking at it, you can figure it out, right? It's going to be 11 plus 11, 22. But can you reason that out? You can draw and label a diagram to represent a telescope. How do you know their vertical angles? How do you reason that out? You can use angle addition postulate to find the measure of angle BDC, right, which is 22. And BDC and EDF are vertical angles because they're formed by two same lines, okay? So you can use the vertical angles theorem to determine that angle x is also going to be 22 degrees. So the outermost light rays form a 22 angle as they leave the focal point. So the value of x is 22 is our answer. Okay, so you can use the theorem to figure out algebra in real life as well. Try number 2. Find the value of x and the measure of each labeled angle. See if you can figure out x and then figure out the angles by yourself. Make sure you're not stopping when you figure out the x. X is not the angle. You need to figure out the angle after you figure out x. Okay, come back when you're ready for answers. Are you ready? All right, part A. They're vertical angles, and they have different expressions, but you can set them equal to each other. 6x minus 45 should equal to 40x plus 5 because they're vertical angles. Vertical angles have the same measure of their angles, right? So now it's a matter of solving for x. Simplify, and solve for x. So add the like terms. We don't have like terms in either of the sides. So what do? You have to subtract some terms. Subtract 4x on both sides. So then you have 6x minus 4x and add 45 on both sides. And that's equal to 5 plus 45. So 6 minus 4 is 2x. 5 plus 45 is 50. X is equal to 50 divided by 2. If you divide 2 on both sides, so that's 25. Are you done? No. Because x is 25, you can figure out the angle by plugging in 25 into any of these expressions. You're going to get the same number. What do you get? 6 times 25 minus 45, or 4 times 25 plus 5 is going to give you 105. Okay? So first of all, your x is 25 is your answer, and then the angle. Angle is 105 degrees. Is your next answer. What about part B? What is your x? So setting up the equation 8x minus 20 is equal to 5x plus 37. You do the same thing. Subtract 5x on both sides, you get 3x. Add 20 on both sides, you get 57. And x is 57 divided by 3, you get 19. So x is 19 is your first answer. If you plug 19 into your equation, 8 times 19 minus 20, or 5 times 19 plus 37 will give you 132 degrees. Okay? Check your answers. If you got both of them correct, good job. If you figured out the x's and you didn't figure out the angles, try again, see if you can get it. Make sure you solve for the angles. Alright, next theorem. 1-2, congruent supplements theorem. If two angles are supplementary to congruent angles, or to the same angle, then they're congruent. Okay, what are supplementary angles? They are supplementary, they make 180 degrees when they're added together. So if measure angle 1 and 2 is equal to 180, then this should be a straight line. And if measure angle 3 and 2 add up to 180, then they should also make a straight line. But angle 2 should be the same. So that means there's only one supplementary angle that is supplementary to angle 2. So angles 1 and 3 must be the same. Okay, we can prove that. We're going to prove that in example 3. Theorem 1-3, another one. Congruent complements theorem. What is a complementary angle? When those two angles add up, they don't make 180 degrees. They make a 90 degrees. So this is supplementary. This is complementary. Okay? Supplementary angles, 180. Complementary angles, 90 degrees. Okay? So the theorem says if there are two angles that are complementary to the same angle, then they're congruent. Okay? Because in the same reasoning, there's only one angle that could be a complementary angle to the same angle. So if they're complementary to the same angle, then they must have the same measurement and they're congruent by definition of congruent angles. Let's prove that in example 3. Write a paragraph proof. Write a paragraph proof of the congruent supplements theorem. What is a paragraph proof? Paragraph proof is when you write all the statements and reasons connected in sentences. So it's like you're explaining it and you're writing down a big paragraph instead of columns, but you're basically writing down the same thing as the 2-column proof, but you have to write it in sentences. So if you prefer to write in sentences, you will like paragraph proof much better than 2-column proofs. If you prefer to just write columns and then reason it out every time, then you will like 2-column proof. Okay, so let's look at how it's proven. By the definition of supplementary angles, measure angle 1 plus measure angle 2 is equal to 180 degrees. Measure angle 2 and 3 is equal to 180 degrees. Since both sum equal 180 degrees, measure angle 1 plus measure angle 2 must equal to measure angle 2 plus measure angle 3. And if you try to subtract both sides by measure angle 2, then you get measure angle 1 is equal to measure angle 3. So by the definition of congruent angles, you can say that angles 1 and 3 are congruent. Now, using a very similar paragraph proof, you can prove theorem 1-3. Write a paragraph proof of the congruent complements theorem. Given that 1 and 2 are complementary and 2 and 3 are complementary, write a paragraph proof. It could be very similar to that. Okay, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? How are you going to start? By the definition of supplementary, we don't have supplementary angles here, so we're going to start with the complementary angles. Yeah, by the definition of complementary angles. What do you know? Measure of angle 1 plus measure of angle 2 is equal to 90, and measure of angle 2 plus measure of angle 3 is equal to 90. Okay, I'm gonna put angle in a moment. Okay, and then what? And then we can say, we can set up an equation just like we did for example 3, right? So by substitution, measure of angle 1 plus measure of angle 2 is equal to measure of angle 2 and measure of angle 3. Okay? And then what? And then you can subtract both sides by the same term, the measure of angle 2. Subtract measure of angle 2 from each side to get what? Measure of angle 1 is equal to measure of angle 3. And by the definition of congruent angles, your angle 1 is congruent to angle 3. There you go. That was a paragraph proof. You just need to make them into sentences, and that's it. Okay. Are we ready for more theorems and proving? Now we're just getting started. More practice. Let's get more practice. All right, we get more theorems. Next page. Look at theorem 1-4. All right angles are congruent. Obviously, but this is a theorem. You have to prove it. Okay? Theorem 1-5. If two angles are congruent and supplementary, then each is a right angle. Now we're talking about right angles. Okay? If two angles are congruent and they are supplementary, they must be a right angle. We're saying that there's no other angle that could be supplementary to each other and they're congruent. All right, theorem 1-6, linear pairs theorem. Now this theorem is very important. You're going to be able to use it over and over again in future lessons. Look at what it says. The sum of the measures of a linear pair is 180 degrees. So if you have a linear pair, that means there's supplementary angle, and if you get a sum of that, that's 180 degrees. You know that, but we are going to prove that in order to reason that out and prove other things. Okay? Example 4 is a proof of this. So let's write a 2-column proof. Going back to a 2-column proof. Given that measure of angle 1 and 2 are the same, and measure of angle 1 is 105, okay, they're equal to each other, we're going to prove that measure of angle 3, which is supplementary to angle 2, is 75. So, first we're going to state the given facts. Measure of angle 1 is equal to measure of angle 2, given. Measure of angle 1 is equal to 105, given. And that means measure of angle 2 is 105 as well by transitive property of equality, right? A equals B, B equals C, then A equals C, transitive property. And so angle 2 and angle 3 are linear pair. Definition of a linear pair. If they're on the same line and they're divided by a single ray or line, then they're a linear pair, right? And that means their measures are going to add up to 180 degrees by a linear pairs theorem. So if you add 105 plus measure of angle 3, you should get 180 degrees by substituting this into this equation, because we know measure of angle 2 is 105, right? Now we can solve for the equation and say measure of angle 3 is 75, and that is all we need to prove what we need, okay? All right, try number 4. Write a 2-column proof for the given fact that measure of angle 4 is 35, and 1 is equal to 2 plus 4. Using that, prove that measure of angle 3 is 70. See if you can write your own 2-column proof. Make sure you state the given information first, and then think about how you're going to get to that final statement in order to prove that. Okay, are you ready to check answer? This is your last try it for the lesson. All right, let's look at the 2-column proof. We're going to write a statement section and then the reasons section, right? So first, what do we have? The given statement. Measure of angle 4 is equal to 35. And using that, this is 35. We're going to use this information later, that measure of angle 1 is equal to 2 plus 4. But right now, in order to use it, before we use that, what do we know? 4 and 2 are vertical angles. So that means 2 must also be 35. So let's state that as well. Angle 4 is congruent angle 2 by vertical angles theorem. And then say that the measure of angle 4 is equal to measure of angle 2. Notice that when you're talking about measurement, you can write an equation because we're dealing with numbers. But if you're talking about the angles and lines and something that's not a measurement, we have to write them as a congruency statement or similarity statement that we're going to learn later on. But we cannot just say they're equal to each other. They're congruent, okay? Measure of angle 4 is equal to measure of angle 2 by definition of congruent angles, okay? And then that means measure of angle 2 is equal to 35 as well by transitive property of equality. And then use the given information. Measure of angle 1 is equal to measure of angle 2 plus measure of angle 4, given. And what do? We know angles 2 and 4, right? So measure of angle 1 is equal to 35 plus 35. By what reason? Substitution, because we already know that they both equal to 35. Substitution, property of equality. And then what? And then we just compute, right? 35 plus 35 is equal to 70. And we can say that we simplified. And then what are we trying to prove? That measure of angle 3 is 70, right? Now we just proved that this is 70. How can we prove that measure of angle 3 is 70 as well? They're vertical angles, right? So measure of angle 1 before we talk about measures, we have to state that they're vertical angles. So angle 1 is congruent to angle 3 by vertical angles theorem. And then we're going to continue here. That means measure of angle 1 is equal to measure of angle 3 by definition of congruent angles. And finally, we can say that measure of angle 3 is equal to 70 by transitive property of equality. Phew. It's just very tedious because you're listing them out one by one and it looks like a lot, but you can actually think through this logical statement in just a few seconds. So that's your planning process before you write a 2-column proof. Before you write a proof, think about how you can prove it. You're gonna hide the fact that measure of angle 3 is gonna be 70. Try to figure it by yourself. Start with the given information. If that's 35, then that should be 35. And if these, if 1 is equal to 2 plus 4, then 1 must be 70. And if 1 is 70, then 3 must be 70 because they're vertical angles. And you have solved it by yourself. Now you can write a 2-column proof using the exact thought process that you have had in mind while solving it. Does that make sense? I hope it does. Okay, so we are going to summarize our lesson. What did we learn in this lesson? A lot. We learned a lot about theorems, proofs, 2-column proof, paragraph proof, and some notations, right? So proofs use given information and logical steps justified by definitions, postulates, theorems, and properties to reach a conclusion. It is part of a deductive reasoning, and it is a strong reasoning skill. So for another example, if you're given that angles 1 and 2 are vertical angles, and you want to prove that they're congruent, you can write the proof in 2 different ways: 2-column proof, paragraph proof. There are numerous other ways to write proofs, but these are the 2 proofs that we learned today. Notice that they're the same proof, they're just formatted differently. So 2-column proof, you start with given statement, you write all the statements down and all reasons down in 1 column. And for each step, it's really clear that you have a corresponding reason, okay? Even if you don't have a reason section in paragraph proof, you do have to reason out why. So you're gonna use a lot of sentences that starts with by something, by some theorem, by some postulate, or by this given information. It's this, right? So yeah, it's okay if you repeat a lot of sentences that are the same format. It's not an English class. You can write proof however you want. As long as it's structured and as long as it's reasoned out, then it's fine. Make sure you have a reason and a statement in a sentence as well. Okay, that was lesson 1-7, writing proofs. And now, if you have any more questions, please feel free to ask Ms. Kang in class. Otherwise, we'll continue with our last lesson of the topic, which is indirect proof, in the next video. Looking forward to the next lesson. All right, see you. Bye.